Hello students, welcome to lecture of Kinematics and Theory of Machine. Myself Professor Shailesh Patel, and we are going to continue gear chapter. Topic we will cover in particular this lecture is an example based on length of path of contact. So first of all, before starting this lecture, you must see all the formula list for this particular chapter. Okay, let's start example of gear. Taking the first example of gear. So pinion having a 30 teeth, drive a gear having a 80 teeth. The profile of gear is involute with a 20-degree pressure angle, 12 mm module and 10 mm addendum. So this data is given, you can see underline here. Let's put on. So this is the data given. Teeth 30, capital T 80, second gear teeth, pressure angle phi 20, module 12, addendum 10. So what we have to find? We have to find the length of path of contact, means Kp plus PL, Kp plus PL, and arc of contact and contact ratio. These three things we have to find. So first of all, you know that for Kp and PL you have to find small r, capital R, and addendum radius for the both. So pitch radius and addendum radius. So first of all, we can find the pitch radius by this equation. You know that equation is equal to mt by 2. So pitch radius for the pinion is a mt, small t by 2, and for the pitch radius of wheel, larger wheel, is capital R is equal to m capital T by 2. So put this value, check this out. M is already given 12, so 12 into T 30 by 2 is equal to 180, and m capital T by 2 is 480. So you have find the pitch radius for the wheel, pinion and the wheel, 180 and 480. And after that you can find the addendum radius. What is addendum radius? Addendum radius is radius plus addendum, pitch radius plus addendum. So you have already find the pitch radius, plus add the addendum. Addendum is a 10 mm. So addendum radius will become 180 plus 10 190, and 480 plus 10 490. So that's how, this is the basic requirement always you have to do. Pitch radius small r, capital R, and addendum radius capital R, small r. Always first find these things. Okay, and now we are going to start find the length of path of contact, Kp plus PL. Kp is a path of approach, PL is a path of recess. So let's start with Kp. It is equal to under root r square minus r square cos square phi minus r sin phi. You already know that capital RA and R. Capital RA is equal to 490 and capital R is equal to 480. Okay, and phi is a 20. So put this value in data, 490, 480 cos square 20, and this, and you can find this Kp 27.3 mm Kp. Same method we will find PL. Formula is little bit different. Small r square minus small r square cos square phi, small r sin phi. Small r is a 180, small r a, addendum radius 190. We will put this value and we will find the PL. So example of gear are very easy. First of all, you have to go through the formula list, and all formula must be remembered. So here we find the PL. PL is a 25. So you have find the path of approach, and after that path of recess. So what will be the length of path of contact? You already know that K2L is equal to Kp plus PL, and Kp is a 27 and PL is equal to 25. So final KL is equal to what? 52.3 mm. Okay, so we have find the length of path of contact here. So remaining will be arc of contact and contact ratio. So let's find that. So now length of path of contact will be useful in our next point. So it is the length of arc of contact. You know the equation. Length of arc is equal to length of path by cos phi, and length of path is already we have find it 52.3. So 52.3 by cos 20, and you will find the 55.66 is the answer. Now we are going to find the last point, contact ratio. Okay, so what will be the contact ratio? You know the equation. Contact ratio is equal to length of arc of contact divided by PC. PC is a circular pitch. PC is equal to, you can find the pi into m. M is already given in our data. M is a 12 mm. So PC is equal to pi m. Pi into 12, it is 37.7. So now you will put this value as a pi m, and arc of contact you already find it, arc of contact. So put the both value in formula and you will find 55.66 divided by 37, 1.5 is the contact ratio. Okay, so this is very easy and basic example. You must go through the formula list for a couple of times, otherwise you will forget or maybe make some mistakes during the exam. So we are going to start second example. It is little bit different than first example. Check this data. So first of all, pair of gear having a 40 and 20 teeth, 40 and 20 teeth respectively, rotating in a mesh, speed of smaller pinion is at 2000 rpm. Determine the velocity of sliding. What we have to find? Sliding velocity of gear teeth at a point of engagement, at a pitch point, at a point of disengagement. We have to find the how many speeds? 3 speeds. If the smaller gear is a driver, assume that phi is equal to 20 for involute profile. Addendum is given 5 mm and module is given 5 mm. Okay, so for write this all data here. So as you can see, 40 already given, 20 already given, addendum is given 5 mm, and module is also given. Phi is equal to 20 and RPM is given 2000. So all this data is given, and now we are going to start. First of all, what we have to find, what they have asked. So first of all, I have also shown you that velocity. We have to first find this velocity of between engagement and disengagement. Okay, so we have to find the sliding velocity, engagement, disengagement, and angle turned by the pinion. Angle turned by the pinion. Okay, so let's start. So you know that for the finding the velocity equation is a omega 1 plus omega 2 into kp for engagement. Omega 1 plus omega 2 into kp for engagement, and omega 1 plus omega 2 into PL for disengagement. So first of all, we have to find the kp and PL for that. Okay, so procedure will be the same as last example. First of all, we have to find the pitch radius of pinion and wheel mt by 2, mt by 2, it is mistake here, m capital T by 2. So you have find this, it is 50 and it is 100. After that you will find the addendum radius. Addendum radius for the pinion is a 55 because addendum is given 5 mm. So add this 5 mm in both. 55 is for the pinion and 105 for the wheel. So after that we will find the Kp. Equation is the same, capital RA square minus R square. Capital RA is a 105 and R is 100. Put in equation. And we will find 12.65. And after that we will start for PL. Formula is the same but small ra and r, whose value is a 50 and 55. Put that in equation and we will find 11.5. So Kp plus PL means length of path of contact is a Kp plus PL. It is not asked in question but it is used indirectly. For the engagement, find the engagement velocity and disengage velocity. Kp and PL will be used individually. So Kp is equal to 10.65 and PL is equal to 11.5. Okay. So first we have to find the omega. Omega 1 means angular velocity. We have already given the RPM. So we will use 2 pi n upon 60. N is the RPM of pinion. So RPM angular velocity we have find is 209.5 radian per second. But after that we have to find the omega 2. For that we are using this relation from the starting. Is omega 1 plus omega 2 is equal to capital T by small t, making the omega 2 as a subject, and you can find 104 because teeth of both wheel is given. Okay. So after that omega 1 and omega 2, you know that sliding velocity at a point of contact. What is omega 1 plus 2 into Kp? Kp is already finded 12.65. What is omega 1 and omega 2? Omega 1 is a 209 and omega 2 is equal to 104.79. So put that value and you will find the velocity of sliding at a point of engagement. And same as we will find the velocity of sliding at a point of disengagement. And for that you already find it the PL. Okay, PL is equal to 11.5 and omega 1 and omega 2 is already find it. So put that in a formula. You will find the velocity at a point of disengagement. Okay. So after that, last point of our example, which is asked that angle by the pinion. And you know the formula for the angle turn by the pinion, which is length of arc of contact, length of arc, which we have to find first, and after that circumference of the pinion. These two things we have to find first and second, and then we put that in this formula so we can find the angle through which pinion is turned. Okay, so let's start. First of all, we find the length of arc of contact. How can you find the length of arc of contact? Is equal to length of path of contact divided by cos phi. Okay, let's start. So KL by cos phi, you have already found out the KL is equal to 24.5 by cos phi means cos 20, and arc will be 25.7. After that, circumference of pinion is equal to 2 pi r. R is equal to radius, and radius is a 50, so it will become that. And angle this same formula. Put this all in this basic formula of angle turn by pinion, and you will find that 29.45, it is the angle turn by the pinion during the contact. Okay, so that says this is the end of our second example, and I am hoping that you all will practice all others example from this chapter. Okay.